First, I'm going to define a random-looking function, and then later I'll tell you why this function is important. I'm going to call it Collatz, Collatz. And I choose my variable name here, n, because the input to this is going to be a positive integer. And for me, x, I sort of think of x as being a real number, and I think of n as being a positive integer, or at least an integer. But not important, just letting you know what my thinking is for this. And I'm going to use the keyword piecewise again. And this function, it's going to be defined as 3 times n plus 1. And n, I'm not going to say something like n greater than 10, something like that. Instead, I'm going to say 3 times n plus 1. That's what I do if n is odd. So how do I represent that? With this odd q function. So this says that if I plug in n and I get a true here, then the function I evaluate is 3 times n plus 1. What about if n is even, which is going to be the complement to this? Then we divide by 2, n divided by 2. So let me give you some examples. Say I do Collatz of 7. 7 is odd, so I do this first part. So then I get 3 times 7 plus 1, which is 22. And there's a famous conjecture in number theory which says that if you start with any positive integer and you keep applying the Collatz conjecture again and again, then eventually you get to the number 1. Eventually your output is 1. So as an example, if I do Collatz of 22, I get 11. If I do Collatz of 11, I'm going to get 3 times 11 plus 1, so I get 34. And I could keep doing this, but remember there's a built-in function in Mathematica that says keep applying this function. So let me show it to you. It is called nest or nest list. And remember how it works. The first part is the name of the function. Second part is the starting value. Third part is how many times do you want to apply the function. So let's start at 7, which goes in the middle. The function we apply is Collatz. And how many times do I want to apply it? Let's apply it 20 times. And remember, the Collatz conjecture says that no matter what my starting value, so whether it's 7 or some other positive integer, eventually I will get to the number 1. So if I look at it, 7, 22, 11, 34, and if I just choose any random one, like I choose this 40, that's an even number, so I divide by 2, and I get 20. And then you can see here, eventually I got to 1. What if I wanted to just continue applying Collatz until it gets to 1? Well, that's what I can use nest while list for. So nest while list. The syntax is very similar for the first 2 pieces, or it's the exact same for the first 2 pieces. It's the function, it's the starting value, but now it's supposed to be some true-false expression, and as long as that expression is true, then I keep applying Collatz. So when do I want to keep applying Collatz? I want to keep applying it as long as my value is not 1. So I'm going to do that with one of these pure functions. So pound, that's like the variable. Not equals. How do you do not equals in Mathematica? You do exclamation point and then an equals. So as long as it's not equal to 1, and then you always finish these pure functions with this and symbol. So very similar to what I did up here, except I didn't have to know how many times to apply Collatz. So up here I said apply it 20 times. Here it just says keep doing it until you reach 1. Let's try it for a different starting value. Let's try it for 10. So here it's something shorter. Let's try it for 100. Here it's something that looks a little longer. If I want to know how many steps did it take, I can apply length. So it took 26, or maybe it took 25 steps, because we started with 100 and then applied Collatz 25 more times.